Hello, everybody. My name is Harald, and I want to walk you through this case study of ours, which is about process transparency or process mining, and it's set in a hospital. Now, I want to talk about briefly about the background. What is this perioperative process in the hospital? The process discovery that we have applied there, and a couple of insights that I want to get across. For instance, process mining is a very useful tool, particularly for work with data. And data analysis is not always very hard. In this case, it wasn't actually. You can get some insights from this, and well, empowering people is magic in the end. Now, unusually, I want to speak about myself for a little bit. I usually don't torture people with my CV. This is just to say, I'm an old white man. You saw that already. I've been around for a while, and I've been in a number of places, a number of affiliations. So when you said you don't have a science contribution today, I'm sorry, I'm messing that plan, because what I'm doing is partially science. And I've been with QAware for almost 10 years, and which is obviously where I work. And somebody asked me, "Oh, will you speak about QA?" And I said, I don't really like to. And Nina made me put in this slide, so Nina, it's your fault. So I have to speak a little bit about QAware. When I'm asked what is QAware doing, because it's 250 people, so a fairly small company, and most people don't know it, never heard of it. Who has heard of QAware before? Let's ask. Some people, right. And when I describe it, I say, well, it's a boutique software engineering company. So we're a classic software project company. We're making software, information systems mostly. And we're boutique in the sense that we are very high end. So when your customer is having some older, new business critical piece of software that is really differentiating them from their competition, and they want to apply transformative technology, used to be cloud, today that's AI. And all of these comes together, and they don't dare give it to somebody else or so, then that's QAware's job very often. And so we are the ones that you call, if I may say so, if success is a must, because we deliver guaranteed full stop. We actually do. We give a guarantee. And we never had to pay money yet. So let's keep our fingers crossed. Now, I want to talk about data mining and process mining. And this stuff has been published before. So if you look for my name out in the world, you'll find some papers there. Why are we dealing with this in the first place? Healthcare expenditures are massive. So for instance, you can see here the red bars are 2020 and the blue bars are 1980, so 40 years difference. And you can see that numbers have doubled or tripled, right? The big one in the top, that's the US, has gone from 8.2% of GDP, sorry, to almost 20%. Germany has gotten from 8.1 to 12 point something. This is the whole West. That is the amount of health expenditures, so spendings in the healthcare system in these countries, measured in percentage of BIP. That's a lot of money. And in Germany, that's 500 billion plus. That's from 2024, I think. So that's a lot of money. And even worse, it's getting more. So if you look at the parts or the sectors of the healthcare system where this expenditures comes from, you can see the largest part is from hospital treatments. That's a big one that is at 2 years ago, 33%. Now, if you look in the media, you have to look very closely, because some people will tell you, oh, hospitals are not so bad. We actually decreased over the last couple of years, which is true if you look at this chart. However, that is not true in absolute numbers. So they have increased a little bit less than everybody else. So what you can see here is over the last couple of years, the healthcare expenditures for hospitals. And you can see that's a massive increase every year. Year after year, we have more money going to the healthcare system. So what can we do about that? For context, anybody recognize this? Oh, that's Großhadern. Yeah, some people. So anybody ever been there, seen it from the inside?
No.
One to a couple people, I would expect that, because that is one of the largest hospitals in Germany, and certainly the largest here near and far. And I've seen that from the inside a couple of times, I must say. And I live next door, basically, which was practical if we went there for interviews, because I had a very short commute by bike. Now, that is one of the largest hospitals in Germany, 5,500 staff, 300,000 cases per year. And the fun fact here is that the surgical procedures account for 40% of the expenses and for 60% of the revenue. Now, it's a hospital, you would think that, right? But then there's also all the stuff that is not directly connected to surgical procedures. But you can see from these numbers, if they can improve even just a little bit in the operating domain, then it'll mean a lot of money is to be saved. And if you just scale that for the whole healthcare system, you can imagine how much money is to be saved if we can improve it here, right? Now, this perioperative process I mentioned a couple of times, that's the process all around the operation. So getting the patient admitted to the hospital, getting him from his bed into the operating theater, getting him anesthesia, preparing them for the operation, doing the actual cutting and stitching, getting them out again, making them wake up and whatnot. So the whole logistics around the operation, that's the perioperative process. Now, there is this company called Squire Medical, which is a startup also based here in Munich, which is a company that we, QAware, have a stake in. So we're tightly connected with them. And they provide IT infrastructure and services and software for patient logistics in hospitals. And I think they have quite a number of the largest hospitals in Germany. So the Universitätsklinikum Schleswig-Holstein, which is, I think, the third largest in Germany. And they're now in NRW, covering some pretty large hospitals, and they have covered Großhadern. So they are, if you have to go to the hospital, there's a fair chance you'll encounter their software on the receiving end. As I said, QAware has a stake in Squire, and our stake is not so much money, but services. So we provide software engineering for them. That's our participating. That's what we partake in this company. And so at some point, they came to us and say, well, we have this great solution, and it's fantastic, of course. And we want to make it even more fantastic, but we would like to analyze data there. And we think we want to do some process mining. Can you do that for us? And we said, of course we can. Learned about data mining then and did it. Now, as you do, right? Now, first up, I mean, every talk should have something for everybody and a little bit for the specialists. And this is the everybody bit, so the base education if you want. If you've never heard anything about process mining, this is for you. And you might have heard of business process management and business process modeling and all of this, and how is mining on observability and transparency and how does it all go together. Now, first of all, you have the classic process mining. And what you do there is you take event logs from the IT systems that run whatever process it is they're running. And you grab this data, you analyze this one time, and it's on historic data. So basically, after that, you know what the systems have been recording 3 months ago. And that is great. You can deliver a great number of insights from that. So that's very useful. That's a big data. Another Munich startup, Celonis. Who knows Celonis? Ever heard Celonis? Yes, okay, many more. Of course, Celonis is one of the German unicorns, and that's their business, right? They take data, they made that a big thing. They made that an industry. Great company. Now, on the other hand, you have process observability, which is not just take it what it used to be like 3 months ago, but take the data as they come in real time and analyze them not once, but continually. And then you have the chance of interactively visualizing that and showing it to the people that work this process. In this case, the hospital, which is great. And by visualizing the process, you can empower the stakeholders, the process stakeholders. So the nurses, the medical staff, and whatever, they see what's going down. Or if you take that in a production company, you see what's on machine, whatever, in production lines, such and such. And that's a great thing because very often, in our experience, when people see visualization of the state, they can figure out what's going on before any kind of anomaly detection hit on. And before anybody gets into action, they see what's going down and they can jump in and fix it. So that's the best kind of process improvement that you can possibly get simply by showing the current state in a real-time way. So that's a great thing. Now, of course, there's data science, which is the analysis part of this, and that's also part of that. And if you have particular KPIs that you want to test, if you have particular hypotheses that you want to test, then that comes in. You have the classic business process management that not so many of you, but certainly I had when we were back in university. And so you focus on people and tasks, and you write beautiful big pictures of models, and you put that in tools and spend months and months doing that. And funnily enough, that is still happening large scale. So there's many companies making a living out of that. And on top of that, that's where QAware's business is. We try to use that as a vehicle to get into improving the systems. That's really our business, to take those IT systems and make them better. And it would be exaggerating if I said we weren't interested in the processes, but really we think that the underlying cause is the systems, and we should fix those and not just the process on top. Now, in theory, we have some process. So in the middle, this is supposed to be my process here. Does that work? Oh yeah. So we have a bunch of steps that happen in a pretty sequence. We have a bunch of people that, okay, not anymore. We have a bunch of people that work with these steps, and we have a bunch of systems that are supporting these steps, such as Salesforce, or R3, and stuff like that. Now, if you look at the people and the processes, then you have classic business process management, right? You write models of these processes, and that's just fine. And you have companies like Adonis or Aris or Signavio that do that. And on the other hand, you have companies like Celonis that take the system approach and look at the data. And that's also great. That's also very insightful. And usually that's fairly cheap, right? You don't have to trawl the whole organization 3 months with 50 people and dig out all the facts. You just go into your SAP system and switch it on, and you get the data in theory. In practice, I'm afraid, there's a bunch of other things happening. Some of these steps are on paper, on Excel, not documented at all, documented in some other system. Sometimes there's other systems, as I said, they have no connection to any of the big irons, and they have software running on them that has been around for decades, and nobody knows how it's working. And they do not have logs, and there's no way of getting to the data easily, and certainly not by just looking at the SAP tables. So that doesn't work for those systems. And then, of course, you have other people involved that you haven't discovered yet, and you may not even want to or allowed to look at. So the real life picture is a bit more complicated than this nice, pretty thing where you just switch on your tool and that's it. So if ever you've been in a shop where they use Celonis, I'm pretty sure you know what I'm talking. Now, so if you want to have this complete picture of what we call process transparency, you need both angles and more. You need to look at the people, you need to look at the systems, and not just the big irons, but everything. Now, coming back to the perioperative process, I said that I'm living next door to Großhadern, and that made it very easy for me to just go there on my bike and talk to people. That's what I did. So I went there and talked to the operation planner, to the doctors and whatnot. And the first observation that we made is it is not this one process. Everybody has a different picture. They name steps differently. They delineate steps differently. So one person said, oh, my responsibility is up to this point. Another person said, no, 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 your responsibility is up to this point. And they disagreed on where that goes. So that's the problem where the classic talk to people approach absolutely is useful. And that's the first thing that we discovered. We had to create this model, tiny model it is, to just be able to talk to people and agree on what we're talking on. Now, the second observation, when we looked into the data, that this perioperative process actually shows up in all its details. So it's not just this one thing, but it's a sequence of steps. And of course, the names of the data probes are completely unrelated to what people call it in real life. So you have to figure out which is which, and it's not always nicely aligned. In this case, we were lucky because we could find some data and that we nailed down to certain steps in this process. So we were able to have this overall process of induction, preparation, procedure, recovery, and refine that into steps. And these things on top here, that's the actual names of the data items, so the columns in the CSV file, if you will, that we would analyze. So the observation is the process actually is there in the data, which some people denied upfront. Now, if you do classic process discovery, this is something you get. Your PM4Pi, you might know that. That's one of these standard tools. and you dump your logs in it, and what you get is one giant net. So it folds everything together. Now you have a bunch of different processes. So what you need to do here is you need to refine this, condense it, analyze it, extract all these individual flows, so that you can make sense of this, because that is not good enough to make sense. And without this domain understanding that we gathered beforehand, that would have been very, very difficult for us. If you're always analyzing procurement processes in SAP, and of course you know at some point what procurement is about, and that's that. But if you're going into a new domain, that doesn't work. So here, this is a new domain for all of us. And so we had to get some domain knowledge first up, right? So if you have a standard domain and a standard tool, you don't have that problem. Any other situation, you do have that problem. So you have to understand it. Now, when you do that, you get, this is actually a screenshot from the tool from Squire. You get this visualization where you have these nice flows, and you have wide lanes with the big processes where many patients get along, and you have the small ones, and you have loads of funky features. If we have time, I can give you a demo afterwards. And that's really useful. As I said, people, when you visualize the actual state, they can already derive helpful insights from that. Just showing it on the station is useful already. So up that point, that was a perfect success up to this point. And of course, you'll get greedy, right? You think, let's analyze some KPIs. And you can do that, right? Again, a screenshot from the Squire system. You can look at individual patients and derive KPIs from that, and you can update that continuously. That's really, really great. And all of a sudden, you don't just have an opinion, you have data, and you can tell them what it's like and not. Of course, you can have very important KPIs, and there's one that I want to highlight that's called plan stability. So what they do in the hospital is they plan for operations. So tomorrow you get an appendicitis, and the day after you get whatever, your leg cut off, something. No, okay, maybe not. Maybe next day. Now, so they make this plan, right? And the main objective is to have a maximum utilization of the operating theaters. A lot of capital is bound there. They need to utilize them as much as they can. So they can't just over-plan, right, and making like 2 hours for every operation. Then they would be poorly utilizing the OP. And they can't under-plan, because then they would have to push on the operations. And whenever a patient is in the hospital, admitted to the hospital, but not yet undergone surgery, they can't reimburse that from the health insurance. So that's that's a lot of money for the hospitals. So they have to make sure, absolutely make sure that do not push them on the next day. Now you'd say, okay, let's just have some extra hours for the doctors. Well, talk to the doctors about that. They don't like it. And the staff doesn't like it either. And it's not so good for you as a patient also. So nobody wants to push the schedule into the next day. So you really want to have a high plan stability. So basically, every operation takes place plus minus the time that is scheduled for. That's exactly what you want to achieve. Keep that in mind. We'll come back. Now, the next observation by talking to people is there's many, many factors that would introduce potential influences on the duration of the overall process. So there's the duration of the induction, there's the duration of the recovery, preparation, and the procedure as such. And all of these partial durations contribute to the overall duration. And so we figured out what would be the influences. So if it's a dashed line, if it's surrounded by the dashed line, then we don't have data for that. So we hypothesized that could be an influence, but we couldn't check. So for instance, age certainly has an influence on recovery, because very young patients and very old patients have very different times than average adults. Also the positioning, so the way somebody is put on the operating table. If you're just like laying down or prone, that's easy. But if you have a surgery on your shoulder and you have to be positioned in a certain way, that takes time and it's difficult. You have to have two people maybe to position that person, and all sorts of funny things going on. So these are factors. Note that the context factors like hospitals, clinics, and surgeons were not analyzed, not because we didn't have the data. Well, we could have gotten the data, and they wanted us to, but we refused to, because that would be personal data. from the surgeons, for instance. And the doctors would actually have liked us to analyze that. And we said, that's too touchy, we're not doing that. Turns out, actually, that makes our analysis stronger, not weaker. Fun fact. Now, this is the causal model of the factors pertaining to duration. And that was also an insight that there's many of them, not just one or two, but many. Now, when we analyzed the factors and looked into the data, this is what we had. We had 11,000 something rows in our data set, if you want, that described procedures with anesthesia. Side remark, the data that we got was covering a whole year, right? And from this data, we could only extract 11,000 that had proper data. If you're talking to people in that domain, they'll tell you how poorly the doctors comply with the requirements of entering data. So basically, if there's a step that requires manual entry, forget about it. You won't get any meaningful data. So the only data that you can actually use is automatically gathered data. And we had 11,000 of those. You'd say, come on, 11,000, that's a big bunch, right? But there's also several hundred different types of procedures. So that makes that for very small buckets. And there's, of course, there's not a proper field in the database that says this procedure or that procedure. There's a text field. And as you can imagine, people will write anything in that text field, right? And so we had more than 2,000 distinct descriptions. And of course, on top of the actually different procedures, you'll have typos, differences in abbreviations, differences in leg amputation or amputation leg, right? So you have to somehow cluster all these descriptions. And that's not so easy, because if you just do that automatically, you'll get something like 135. But if you ask clinicians how many of these are actually different, you'll end up with 15, right? That's almost just 10%, a little more than 10% of these 135. So most of these clusters that you get by automatically clustering, and that includes AI clustering, are useless. Without the expert knowledge, you could not do this. Well, and even only half of those were meaningful in a practical sense. Now here, I give you some examples. So for instance, some people write MS and some people write Magensonde. The Levenshtein distance is pretty large. I'll hope you agree. There's also Art and Arterie, or Art Wach, or Wachart, Wach.art, Wach-Art, Wacharterie. And those are different from Arterie. So, right? I mean, similarity doesn't help you here. You have to really know what they are talking about. And that's very difficult. Now, so basically this clustering of 11,000 into 7 meaningful, that is something that you cannot do automatically. And I can't see in the next couple of years a situation where you can do that automatically. So that will stay with this for a while. So observation 4, expert knowledge is crucial if you want to do this analysis. It's not about just data mining, it's also about people. Now, next observation, the actual and the planned duration deviate greatly. So what we can see here is the actual operation duration on the x-axis and the manual plan, so the planned one that has been done manually, on the y-axis. And the diagonal is identical, so planned is as actual happening. And you can see this is not at all what is the case, right? It's all over the place. And we said, okay, plus minus 20% is good enough. And it's not in that yellow area in any way, right? It's completely all over the place. But you can also see that there's some kind of layering going on, right? You can see these horizontal lines. Anybody have a guess what that is?
Bad plan.
Come again?
Bad plan. Bad planning.
Bad planning. Well, this is very bad planning for sure, but the whole thing is bad planning.
Planning round numbers.
Planning round numbers. Excellent. Excellent. Absolutely, that is what's happening. People plan on round numbers. So if you draw the data a bit differently, you'll get this. So you have the green ones. Does it come out as green? Yeah. So the green ones is the planning data, right? And you can see there's peaks every 15 minutes. And the yellow is the actual times. Now that's a nice smooth distribution as you would expect, right? And so that's exactly what's happening. They say, oh, 15 minutes, 30 minutes. Oh, let's be 25. You never say, oh, I'll be there in 7.5 minutes. You don't say that, right? I'll be there in 5. And that's exactly what's happening here. So can we improve on that? Oh, hell yes, we can. But how? Of course, we want to take the data, put that into some fancy machine, and come up with a number that is automatically generated, computed, and tells us for whatever factors, and you remember the factor model, how many minutes or seconds that operation will take, right? Based on the sex and weight and age and procedure and whatnot. Let's see. First up, the actual durations are a lot shorter than the planned durations. So if you just compare them this way, you'll see that the planning is very careful. And again, a human kind of understandable behavior, let's be on the safe side, right? That's what you can see here. And that is not good for plan stability. You want them to be coinciding, if possible. Can you repeat that, whoever said it? It's maybe good for patient health if we give them a little more time. Well, it's good for those patients that get treated until 4 o'clock when they really want to have their shift over. And it's also good for everybody else coming after 4 o'clock. Yeah, right. If you're on the other side, okay. Anyway, ideally we would want to have these to be coinciding completely or perfectly, right? That would be the ideal goal. Now, what we did, in fact, not me, but a master student of mine, a very eager young master student, she tried each and every predictive method in the book. And here's a couple of candidates. As you can see, I grayed out the legend because that's a homework assignment for you. Can anybody guess what the various bars are? I mean, what you can see is most of them are close together, but the green ones are different. Now, the fun fact is, are the green ones the real ones? And the rest is whatever machinery we could muster. And why is all of these machineries similar? And what are they? Any guesses? Some of them are models for sure, but which? Yep, that was part of the mix. Well, we tested pretty much everything you can think of, and only a few are represented here, and that's the best ones. Can anybody guess what our gold standard was? So what did we compare all of these to? What would you do if you would compare whatever data to just like make the most simple estimate? What is the most simple estimate you can think of?
Sliding average.
Linear regression average?
Sliding average.
Sliding average? A constant. So a constant is definitely the simplest you can think of, right? Very good point. You beat me. The second simplest that I could think of was average. So the arithmetic mean. And the arithmetic mean is in that. Now let's see which is which. So the green is the manual plan. Now you could have guessed that from the last slide, right? Because I said it's always overestimating. And the first one here, the bluish, that's the average, the mean, the arithmetic mean, as simple as that. And we had all sorts of random forest and whatever, right? Full AI, full blown, no good. Actually, the average is in many cases better than anything else, and in most cases not far off. And it has the added advantage that it's really simple. And you can compute it live, online, right? Every millisecond, you can have a new average. So you don't have to retrain your model for a week or so. You just flip on the average. That's it. It's as simple as that. And we checked it a couple of times because we couldn't believe it. Yes. Now, that was a surprise to everybody. The doctors didn't quite, they were a little bit underwhelmed from our surprise. They couldn't quite fathom why we were so surprised. Oh, yeah, it's an average. Never mind. Couple of insights for you. So first up, process transparency is more than process mining, a lot more actually. So the conventional process discovery, that's the tool-based extracting of data and then folding this all together. And in real life, you also have a lot of analysis at the back end. You have the understanding part in the front end, and hopefully you have some, you can derive some insights, some actionable insights in practice at the very end. My personal learning here is that if you really want to have good results, you want to combine qualitative and quantitative analysis. And that is something that machinery in itself is very hard to do. So I think your jobs are safe for the time being. So that's a good message here. It's Christmas, right? The statistics part, we have a very high variation. I think you saw this in this free text descriptions. We have a very strong context dependency, and that is pretty much the case everywhere, I would say. And that resists automation and breaks AI. And so my conclusion is, do not go for automation, go for augmentation. And thank God none of my bosses is here, so they can't hear me say that. Because they're really into automation. And I think augmentation is a way better. So just improve the human practice by tools rather than replacing them. I think that's more promising. Now, a couple of takeaways. I think great process mining is a great stepping stone to get data and then do some data analysis that is helpful to your clients, insightful, hopefully. There is lots of low-hanging fruit, and you can have them. You just have to be going there and grab it. Sometimes it's as easy as that. AI is not the answer to every question. I heard this a couple of times earlier over dinner, if you want to call it dinner. And I've had this sentiment on a number of conferences in the last couple of months. I feel that the AI hype is kind of on the downward side of the hype cycle. And everybody realizes now that, oh yeah, it's great, but not so great. And there's a couple of things we can't solve that way. And I hope I have added a number for your repertoire. Doesn't mean that it's not a great tool, right? It's fantastic. But we have to use it where it's due and not everything, right? If your only tool is a hammer, then the whole world is a nail. Same old story. And my base message, which is kind of, as I grow older, I embrace that more and more. Simpler is better, always. And I used to love the complex solutions, and computer scientists and programmers love the complex solutions, right? I mean, we love to over-engineer. You're not a proper programmer if you haven't invented your own database or framework and programming language, right? You have to absolutely invent it from scratch. And no, don't do that. That's not a good thing. Right. And that leads me to the end.